Repair the transom of my boat. The problem started when I tried to mount the transducer of a fish finder on the transom of my boat. When I drilled into the transom, I found the wood material being drilled out was wet and in black color. Yes, the wood inside the transom was rotten. There's no easy way out. I had to replace the wood inside the transom. Luckily for me, the area that needed to be fixed was small. Only the middle of the transom has wood in it. The rest of the transom is made from solid fiberglass. This limits the scope of this project. The first order of business was to remove the outboard motor from the transom. We need three things in order to remove the outboard: hydraulic engine hoist, outboard engine lifting wing, outboard motor stand with wheels. My outboard is an 115 horsepower two-stroke motor, and it is around 350 pounds. All I need is a 1-ton hydraulic engine hoist like this one. 1 ton sounds like an overkill, but actually it was just enough. The reason is that by the time I extend the arm of the crane, its lifting capacity drops down to only quarter ton. That is only 500 pounds. That is just enough with some margin of error. Because I only need to use this engine hoist for a very limited number of times, I prefer to buy it from Harbor Freight instead of a higher price model. This engine hoist gave me a bit of headache in the first time when I used it. When the engine hoist was under load, I found that the hydraulic jack in the engine hoist kept losing pressure, and the outboard motor almost dropped to the ground. I worked around the problem by tightening up the valve of the hydraulic jack. I found that hand tightening the valve was not good enough because my fingers would become painful before I could tighten up well enough. I had to use the tool that came with the hydraulic engine hoist to tighten it up to super tight. I also need an outboard engine lifting wing like this one. Because my outboard is from Mercury, I ordered the one for Mercury. It is mounted on top of the flywheel of the outboard. The engine hoist would attach to it. When we remove the outboard motor from the transom, we need some place to put it. We need an outboard motor stand. Because the outboard motor is 350 pounds, that is quite heavy to move around. We need the outboard motor stand to have wheels. I put 4 caster wheels in my homemade motor stand. 4 caster wheels may be a bit overkill. I think at the minimum we need at least 2 caster wheels and 2 fixed wheels. One thing that I need to point out is that there are 2 problems with my homemade motor stand. The first thing is that I built the motor mount to be at the same angle as my boat transom. This sounds logical, but this is a bad idea. When I tried to mount the outboard on the motor stand, the outboard kept kicking out from the motor stand. It couldn't naturally rest on the motor stand. I ended up requiring another person to force the motor in place before I could secure the motor on the engine stand. If I could rebuild the motor stand, I would have built the motor stand in an upright position. Then the outboard can rest on top of the motor stand laterally. The second thing is that the opening between the two supports of the motor stand is too narrow. The engine hoist cannot move inside the opening and cannot move the outboard close enough to the motor stand. I end up having two persons to manhandle the 350-pound heavy outboard onto the motor stand. That was no fun. The opening between the two supports should be wide enough for the engine hoist to fit inside. If you want to build a motor stand, please keep these two things in mind. There are some tips that I can offer. First, this is a two-man job to remove the outboard. This is easy for two persons to unbolt the nuts, one from the inside, another person from the outside. This is also easy for two persons to move the outboard around after it has been removed from the transom. Mark down all the wiring connections and take a lot of pictures. Tilt the outboard to match the angle of the motor stand before disconnecting the power wiring. If the motor stand is upright just like what I have suggested, we should fully trim down the outboard. Test the engine hoist to make sure its hydraulic jack won't have a pressure nick when the engine hoist is under heavy load. We need to test it before we have removed the outboard from the transom and the outboard is hanging in mid-air. This is no fun to deal with this situation. Despite all the problems that I have encountered, I finally moved the outboard to the motor stand. Now the transom is ready to be cut open. With the outboard motor out of the way, I could examine the transom to figure out why the wood inside the transom was rotten. After I removed the metal trim piece from the top of the transom, I could clearly see how the water got inside the transom. The metal trim piece was hiding a big gap between the top surface of the transom and the vertical side of the transom. The whole of the bowl was composed of two large pieces, the top shell and the bottom shell. The gap was where the top shell meets the bottom shell. The gap was like half an inch wide. It was a big gap. Seems like the only things that the bowl manufacturer used to protect the gap was some caulking material and a piece of aluminum trim. After a while, the aluminum trim corroded away and the caulking material deteriorated. That led water to get inside the transom. Once water got inside, it had no way to get out, and it started rotting away the wood inside the transom. This was a very bad design. Not only the big gap allowed water to get in, but also the top shell and the bottom shell were not joined together. Even if the caulking material has been stayed in place to prevent water from getting in, the big gap was a structural weak point. This has to be fixed. Before I cut the transom open, I did three things. I drilled some holes in the transom to locate the wood inside the transom. I marked down where I should cut, and I make sure I left 3 inches fiberglass around the cut. The 3-inch area was for stacking the joint between the fiberglass skin and the transom material. I marked down all the holes in the transom on the turnplate before I removed the fiberglass skin from the transom. Then I could tell where to drill the holes after I finished repairing the transom. I used a thin piece of plastic sheet as the turnplate. That was okay, but I wouldn't recommend it because it's too flexible. I should have used a thick plastic sheet. I built a canopy over the transom area to protect the work area. The canopy not only kept the work area dry, but also protected me from the hot sun. I thought of tilting the boat forward. Then rainwater that might leak through the boat cover will flow forward instead of pouring in the transom area. I chose not to do this because I was lazy. Honestly, I should have done that. Because I didn't, therefore, I have some close calls when rainwater almost flooded the transom area. I used an oscillating multi-tool with a half-moon saw blade to cut the fiberglass skin. The fiberglass skin came out in one piece easily. The wood inside the transom has rotten to a point that it has a very weak bond to the fiberglass skin. The rotten wood was also removed easily using a combination of the oscillating multi-tool, a flathead screwdriver, a small hammer, and a set of stiff and flexible putty knives. The only difficult part was to remove the rotten wood from the edge where the wood was covered by remaining fiberglass skin. For those areas, I need to use an angle grinder with a chainsaw wheel to remove most of the wood, and then use a chisel to slowly pick away the remaining wood that the chainsaw wheel couldn't reach. Please note that the chainsaw wheel is a very dangerous tool. It is probably the most dangerous tool in my possession. Therefore, I don't recommend you to use it. I mention it because it was what I used. Finally, I removed all the rotten wood from the edge of the fiberglass skin. After all the wood was removed, the transom looked like this. Please note that the wood-like texture was the wood texture left on the inner fiberglass skin. They were all sent away later. Now that I was done with removing all the bad stuff, I could start reconstructing the transom. Before I could start reconstructing the transom, I need to do one thing first. The canopy should be good enough to keep the work area dry as long as rain was light. However, under heavy rain, the canopy would not prevent the work area from getting wet. To prevent my work from getting wet, I need to block off the scupper hole. I didn't take any picture of what I did. This was putting many layers of fiberglass to cover each scupper drain hole and sand the hole flat. The reason why I used fiberglass to block off the hole was that I want to replace the scuppers with something totally different. Blocking off the scupper drain holes was good enough up to a point. If there was heavy rain, the rainwater pouring near the transom could get so much that the water would reach the inspection hole near the transom. Sooner or later, the water might leak through the inspection hole and reach the bilge and find its way to the transom. I had to make sure there was not that much water in the area after a heavy rain. That was the close call that I mentioned previously. I chose to use cruiser board to replace wood. Cruiser board doesn't absorb water and won't rot. It is good for use in a transom. Before I start working with cruiser board, I check the weather forecast to make sure I will have at least several dry days because I didn't want the cruiser board to get wet. Yes, cruiser board is not supposed to absorb water, but why take the chance? I use thin wood strips and hard glue to form two pieces of template. I use two pieces of templates instead of one large piece. This was easier to remove two pieces of templates from the space inside the transom than one large piece. Here I dry fit the cruiser board into the space inside the transom. Look that I have sent the edge of the fiberglass to a tapered edge. That was where the new fiberglass sheet would be attached to. Please also look that I have pre-drilled oversized holes for where the bolts for mounting the outboard will go through the transom. I had also pre-drilled oversized holes for the screws for mounting the transducer of my fish finder. The oversized holes were filled with pieces of fiberglass and thickened epoxy, and then leveled with Red System 407 mixture. This was for reinforcing the holes and to prevent any possibility of letting water inside the transom. This is much easier to do this when the cruiser board is placed horizontally on a work table. This would have been much difficult to do after the cruiser board has been mounted vertically on the transom. I need to use two layers of cruiser board. The seam in one layer was offset from the seam in the next layer. This means if the top layer had a seam across the top half horizontally, the bottom layer would have a seam vertically or across the bottom half horizontally. Please note that cruiser board is constructed with some fiberglass mixed inside. The fiberglass is to stiffen the cruiser board. Because it has fiberglass inside, we need to wear gloves and face masks to protect ourselves whenever we cut it with a power tool. We also need to wear gloves whenever we handle it. Here I had epoxy the cruiser board into the transom. I need to use many ways to tightly clamp the cruiser board to the inner fiberglass skin. The bottom half of the transom was very tight fit. That's why I didn't need to use any wood stick to pass against the bottom. Here I epoxy the old fiberglass skin in the middle as a filler to make up the difference in the thickness. The white stuff surrounding the old fiberglass skin was a thin layer of thickened epoxy to level the surface. And then I used many layers of 1708 fiberglass biaxial mat to cover the entire area. The 1708 fiberglass that I purchased is specifically designed to be compatible with epoxy because many are not. Here I had put on a layer of Red System 407 to level the surface and had already sanded it once. I don't remember exactly how many layers of 1708 that I had used. Mostly likely 6 layers. There are several tips that I would like to offer. We need to figure out how many layers of 1708 fiberglass to put on the transom to match the thickness of the existing fiberglass that we have removed. The simplest way is to put a small stack of 1708 together, pass them down together, and measure the thickness. When the thickness is approximately right, epoxy together, use a roller to squeeze out the excessive epoxy, and then put some weight on top of the stack to keep them together. When epoxy is hardened, we measure the thickness again to confirm that we get the correct number of layers of 1708. In my case, the original fiberglass skin is half an inch thick, so I probably used something like 6 layers of 1708. Normally, when we epoxy a thin layer of fiberglass on a vertical surface, all we need to do is to brush on a layer of epoxy on the vertical surface, and then put the fiberglass right on top of the surface without wetting it first. The epoxy on the surface will stick to the fiberglass, and the fiberglass won't slide down. And then we can saturate the fiberglass with epoxy just by brushing the epoxy on the fiberglass. This won't work with 1708 fiberglass. 1708 fiberglass is quite thick. If we put 1708 on a vertical surface that has been wet with epoxy, the 1708 will detach from the surface because of gravity. We need to put the 1708 on a horizontal surface, like on a work table. Wet both sides with epoxy until the 1708 becomes translucent. At this point, below the 1708 is fully saturated with epoxy. We can now put the 1708 on the vertical surface. As soon as we put the 1708 on the vertical surface, we need to immediately use a roller to squeeze out all the air pockets and excessive epoxy from the fiberglass. Using the roller will improve the surface contact and help the 1708 to stay in place. I extend the fiberglass all the way over the top of the transom and also wrap around the bottom. I believe this should strengthen the structure, and this has an additional benefit of keeping the fiberglass in place instead of having it sliding down. But one thing that I need to mention is that the fiberglass that is extended to the bottom may affect the flow of water under the hole. Therefore, I need to use wet system 407 to level the surface in the bottom to make the bottom surface to be as straight and as smooth as possible. When the fiberglass was hardened, I sent it to wrap up the surface, and then applied a thin layer of epoxy thickened with wet system 407 to level the surface. This is easier to sand wet system 407 than to sand fiberglass. That's why I only warp sand the fiberglass instead of trying to sand the fiberglass to very smooth. I use wet system 407 mixture to fill up the low spot and then sand the surface to level. And I keep doing this until the whole transom was level. There are some tips that I can offer. Use a fairing long board to go over the surface to find out where the high spot and low spots are. Use a 6-inch orbital sander to do most of the sanding. Hand sanding is too labor intensive and time consuming, and a 6-inch sander can cover a larger area than a 5-inch sander. Budget a lot more time in this step than all other steps. Sanding takes a long time, and this takes many times to touch up the surface to make it very smooth. When I was sure that the surface was smooth and level, I paint the surface with off-white color. I used 2 parts primer and 2 parts paint from Interlux. The color was not quite matched with the original color. I'm sure you can see the seam in the picture. but I figured no one will notice because the area is in the back of the bow. I also need to raise the transom up a little bit in order to paint white to the bottom corner of the transom. At this point, the transom was ready. I used the template that I had prepared to mark down the mounting holes. Dry fit the outboard on the transom and then drill the mounting holes. Good thing I have already reinforced the mounting holes with fiberglass and thickened epoxy when I prepared the cruiser board. Then I didn't need to do this here. There are some tips that I can offer. When we mount the outboard, we need to dry fit the outboard and we need to remove the nuts and bolts multiple times. In order to make the job of removing the nuts easily, we should not use lock nuts at this point because this is difficult to put on or off a lock nut. We should get some regular nuts for the purpose of dry fitting the outboard. The mounting holes have to be drilled correctly. We need to dry fit the outboard, mark down the exact location of one single hole, drill one hole, put a bolt into the hole to fix the location, and secure it with a nut. And then drill a second hole and put a bolt to the second hole and secure it with another nut, and do the same thing for the third and the last. This is to make sure all the holes will be in perfect alignment. I also use the template to mark down the screw holes for securing the transducer of the fish finder and the cable linking to the transducer. Finally, the transom was fixed and I relaunched the bow. The boot tapes were there to see if the stern of the bow was getting heavier than before the repair. Turned out the repair didn't affect the balance of the bow at all. Please note that when I relaunched the bow, I didn't drill the holes for scupper just yet. This was done later. Now my bow is back in action. Hope this video is useful for people who need to repair the transom of their bows. Technically, this is not difficult to do. This is just a lot of work. And this can take a long time if you are like me who has to do all the work outdoor and have to wait for the good weather.